So, how are you all doing?
We're doing good. How are you?
Good.
Yeah, good. Seems like there's been some progress in activity, but
Yeah.
no way. You drive. I'm kind of just coming from another meeting, so I need.
Okay. Give me a second. I'll share the screen quickly. Grab everyone the background. Then hold on. So basically, what we're trying to do is come up with a new way of figuring out a way of expressing how we will be representing how we capture closures. So I wrote this doc over the weekend. I sent out to I think everyone, and let me figure out how to. All right, that's where share screen is. All right, and how do okay, give me one. All right, here I found it. Yes. So basically, what this document and list is what we currently have, and I'll quickly go over all of them. So initially, when we do a quick pass over our user code base, and I think this is very soon after we process the AST, we kind of generate for each closure that we have, we generate what local variables we are capturing and map it to a span, which basically tells us which is the last access of that local variable within that closure. So if you look at C1, we over here, we map that we have this closure C1 that uses this local variable, and when P, we just look at the root variable, so that would be P in our case, and we map it to the access, which is the her ID 4 over here. Once we start processing and start generating type information and start building our type check tables, we move on to the structure which is called. We start building these two structures. One is called closure captures. The other is upward capture map. And closure capture is very similar to upwards mentioned, and it maps the root ID to basically an upward ID, which is basically that the root ID combined with the actual closure definition ID. And upward captures uses this upward ID that we generated in our previous step to sort of explain how we are capturing different variables. So in this case, let's say in C1, all we are doing is we are reading the value. So all we need to do is get a reference to P, and that's all. And we're good. But however, if we come down somewhere over here, we are mutating P2. So what we want is we want a reference, and we want it to be a mutable reference. So we see something like by reference, and that's a mutable borrow. And it's possible that we want to move the value inside the closure. So in case of an FN1's closure, we will end up have something like a by value, and the idea is we copy by value, we move the object in.
Yeah, one nit is that move is independent from being FN1s.
Oh, okay.
It actually has more to do with, does that closure keep references into the stack, which means it can't be returned, for example, than to do with how many times the closure is called. But,
okay. And what we want to move on, so currently what we do is we just have a reference to this root variable. So we know that we have P, or we have mirror P, or we have P2 when we're trying to access these variables within the closure. But what we want to express is a lot more specifically and precisely what we're capturing. So instead of saying, oh, we are using P2 here, we want to say we are using the field X within P2. And so I think everyone's familiar, and we have been doing a bunch of work around making what we call a place, which represents how memory is accessed a lot more precisely. So Archer has a PR up to store type information within each access in a place. So let's say if I have p3.x, then I know that I'm starting off from a local variable, or let's say, or a capture variable, which is p3. And what I do is I access the field x from it. Depending on if P3 is a reference or not, we might also have something like, oh, I need to first dereference P3 and then access the field X. So what Archer just finished, and I think it's been approved, is at each step, we store what the resultant type was after applying what we call this projection, which is basically saying, okay, I access field X. One important thing to note is, so place has this field called base, which basically is a place. it represents what our starting position, like where we're starting off. So if it's an upvar, it means you're working off a captured variable. If it's local, that means you're working off a local variable or an argument in our case. So the way this information is generated is so when we do our first, so we start with, in our initial passes, soon after the AST is built, we build our upwards mention, which basically captures what the root variable is being captured and where it's, or how it's being captured in case we need to report an error. And by how, I just mean like the location within the file where it's being captured. And so we basically, at a high level, what you do is we iterate our call flow graph, and we basically collect all the local variables that are there. Once that is done, we start going over and looking at all kinds of accesses, and we figure out which ones were, if we know that the variable we're using was a local variable, we ignore it. If it's a capture variable, we store it in upwards mention, and we collect the span, which again is used for error reporting. During type check process, we start building closure captures, and that's currently very simple. We go over upwards mention, and we create a closure upvar ID, which is basically pairing the her ID and the closure def ID, and we have our upvar ID, and we just store that as a map. Upward capture map is a little bit more subtle, and it's so the way we do it is we define another visitor. It goes and walks our call for graph, and what we do is we define this for a function context. So within what we want to do with this is in type over here is we want to analyze our closures within a function context. So every time this sees a function, the visitor sees a function closure expression. So it will look something like, oops. So it looks something like this within our, I'll zoom in a bit. So it looks something like this within as an expression. What we do is we take the body, we visit the body, and what we do is we go analyze this body, and there's a possibility that when we analyze this body, there's a nested closure, and we'll basically start this whole process again. It kind of goes a little recursively, as you would expect. And once we are done walking over the body, what we do is we go analyze the places, and we store them as captures. And we know, or sorry, whenever we see a place being used, what we do is so we use this thing called expert use visitor, and what it does is it can again walk the whole tree all over again and figure out how each expression is being used. And what it does is it calls into this callback to basically update the borrow kind information. So initially using, and sorry, I skipped over this part, but over here, if we go, we see that we can have sort of hints, and they're also, I guess, required in certain, if you have something like this, you need to mark your closure mutable, but this tells, when we're processing this, that this is going to mutate something, so we can initialize all our capture states as that this is going to be a reference. We need to take a mutable reference. What we do is we keep iterating we slowly go and iterate over all our expressions that are within this closure body, and we try, basically expert use visitor will call in to say, hey, I'm wanting to borrow something, I'm trying to mutate something, or I'm going to consume a particular place. And that gives us an idea to, okay, we need to go and update the borrow kind for how an expression is being used, or how a capture is being used. And that is how we slowly build a stable.
Yeah, a local variable specifically today.
Yes, and we basically build this for the root local variables. And so just to take and if we see a closure within a closure, what will happen is, since we already processed the body of the closure before we started analyzing it, all nested closures have been previously processed completely. So we can just read the list of captures and their borrow kind information and use that to update our information. So just to give a quick example, let's say we have this function foo that has a closure which has a nested closure within it. We'll start visiting details within foo, and we see, oh, we have a closure over here. Let's process that, which means we'll go inside the body and start processing it. we'll see C2, which is again another closure. So we'll start processing that closure first. We process this closure. We see, oh, we're doing a drop A. So that means I probably need to move A and consume A. So we store that borrow count information. Once that is done, once we're done processing C2, and since this is the last thing within C1, we'll start analysis of the closures within C1. So we see, oh, or we start do the analysis on the captures within C1. We come over here, we see, oh, we have this closure expression over here. Now we don't need to process this again because we have capture information for it. So we can just read information for it and update the information about C1 here. Now it did not say move over here. So our initial guess for A might have just been by an immutable reference, but we see, oh, C2 is requires move, so we can consume it in our case over here. And we build this table. Now, again, as I mentioned earlier, the problem is if this were, let's say, a structure and I was only dropping a.x or something like that, we would be dropping the whole structure. So what we want to do is we want to use place. This is more for what we really want to do is we want to use a place to express how we are capturing information and store that captured information. So now we have, so what Nico proposed was have something like we have an fx index map. So the reason we need an index map is I'll actually go over some of these places. So the way the main different kinds we're using it is, so either to get the her ID of the root variable that we're using. So this can be useful just to see how a variable is used, and borrow checker and other places, or while we're building MIR, this is basically what identifies what's being captured so far. Certain places we might also need more than just, oh, if it's a capture variable, more than just that if it's a capture variable, but also how we are capturing it. So if it's a mutable capture, immutable capture, if it's a move. In case we're trying to report errors, there are two ways we can report errors. Either we can report an error saying, all right, you're trying to, there's something that's mutable, or let's say I'm trying to report an error over here which says, for some reason I cannot mutate m of x because it wasn't, let's say I was trying to mutate m of x over here and it was like, oh, you cannot mutate m of x over here because it's not a mutable reference. So I would probably want to give an error over here saying it's not a mutable reference, and that's where you're trying to do something like this, assuming this was, let's say, m_x plus 20 or some plus equals 20. And there's the other concept of definition span, where we might want to point over here saying, oh, this is not marked mutable and we cannot use it in a certain way. So there's the concept of definition span versus access span. So depending on what kind of error we're trying to report, we might need access to the actual expression that captured, that caused a certain kind of capture. Once we start getting into the MIR, well, so we start with HIR and we start to desugar this closure. We try to express each capture variable as a field within a structure. And the way we just represent is like, oh, the first capture variable is, let's say, the first field within the structure. So what we do is we basically add some indexing. So field first capture gets the index 1, well, index 0. The second capture gets index 1. And the reason this is opposite over here is, so if we go and C4, we see that over here, we first capture mirror p.x and then we capture p. Mirror p has HRID 2. Which basically means when we captured, we look at it as if it were the first capture within this closure context. So this has the index 0. And the other one has index 1. Also, feel free to stop me if something does not make sense. I don't know if I'm going too quick here. So basically, this is what we want to do is we want to associate like a capture with an index, and also the other way around. If I give an index, I need to be able to find out what kind of thing I'm capturing. What is the actual capture behind it?
So just one thing. It's time check is we're 17 minutes in. I do have to go at the half hour probably. Okay. So far everything sounds quite accurate. I don't know if you want to, if you depending how much you want to say, you might want to make sure you get to it though.
All right. Okay, that's fair. So okay, what Nico proposed was we have something like an FS index map where we have the her place and capture information. So capture information is where it's being used. So this allows us to get the access span. Capture mode allows us to get, again, it's similar as to capture kind where we store how we are storing that information. Now we are using an index map so that we can satisfy our needs of being able to associate a captured place with an index. And what we want to do over here is, I think this should work for the most part, mostly because her place will have the base place location. So we know from the place base, we know what the root variable is. Projections will allow us to classify things a lot more accurate, will allow us to capture places more precisely. The only thing actually, it might not be in, so there are places where we try to get information based on the her ID of the capture. So we might want to be able to associate, be able to query this map using what the her ID is, or some kind of information related to capture.
So one thing, or two things maybe. First of all, it certainly is possible to make a place from the variable here ID, like very easily. And so we could do that. But one concern I have is I think long-term, we're probably going to want to evolve this structure a few times, is my guess. And in particular, if you think about the stuff that compiles to mirror, I think the way it's going to want to work is going to be an expression like a.b.c, right? And some prefix of that we may have captured. And we can, you're going to recurse it down. So you're going to start from a.b.c, and then that's going to process a.b, and then that's going to process a. That's how it works today. And so we can either, on that way down, detect, this whole piece of expression is actually going to reference a closure up var. Or we could do it on the way up, right? So we get all the way down to A, and we say, oh, A comes from outside. And maybe we don't yet, maybe we actually captured a.b, right? So what we might return then, what we probably, at that point where we're just looking at the A expression, we can't pick which up var we want to use yet because we need to know that it's a.b, but we've gone too far in. So what we might do in that case would be to return something that's like, this was an up var, here's the place so far, but it doesn't yet match any of my captures, right? It's like an incomplete match. And then when we get to the .b, we would say, I'm adding the field B, I'm extending this place, I have that, this is a match. Here's what I want to use. I think that's how we're gonna probably want to do it.
Okay, I think that, I think that does make sense.
And now that I say it out loud, well, let me just finish the sentence, but now that I say it out loud, I see that maybe this data structure would even work for that algorithm. I was imagining we might want more of like a tree-based thing or something, but actually it might work just like it is. But for the interim, I think we would build it like this, and then whenever you have the var here ID, you just make a dummy place with no projections, and the base is always a local variable, and the type is the type of that local variable. And I don't think that type, I think that should work. The type is always.
Indexing the map would require like we can like derive partial EQ, but my concern would be that a.b.c and a.b.d are two very separate. Like they're completely disjoint over here, and if we build a partial place without projections, then we might have conflicts.
Well, for the time being, all the keys are always going to be just a local variable, right?
Yes, currently, yes.
So until we get to that point, but right, I think you could derive partial EQ, and then, but then you don't want a.b and a.c to be equal. They're different places, right?
Yeah, exactly.
The only concern would be if we can't produce the same exact types. I think we'll be able to, because we're getting them.
Okay, I think I get where you're going for. Like in the current one, we just build without projection, and the future when we start doing things, we build it with projections, and then we do the query. Okay, that makes sense. My couple questions is, from a performance perspective, does it make sense to cache some of this information so that we don't have to build certain certain places over and over. Like if we can, does her expression provide some kind of partial EQ in the sense that if two expressions are technically the same,
no,
just different her ID?
No. So here expressions like that's sort of, there's two notions of equality, so to speak. And that's why place exists, to kind of abstract out the same place in different locations from two different expressions in two different locations. That makes sense.
Okay.
I don't think there's a lot of, like, creating a place is cheap.
Okay.
Because there's no allocations involved. It's just an empty vector. It's all nulls. It's fine.
Yeah. Well, that would be again at the start, right? But when we start building the...
Yeah, that's right.
All right.
But it's still not that expensive. You got a vector.
Okay. Another question. So I was looking, so there's like is there anything that we can do to, I guess my question is around incremental compiles. Is there something that we can do better over here that will improve or make incremental compiles quicker? Or is there something that we're doing that's good and that will make incremental compile better? I saw there's a new work group that's trying to, I think.
Yeah, I don't. This is all pretty orthogonal from,
okay.
Not everything you're doing here should fit fine. The incremental, we don't do incremental compilation within one function. Like we don't type check, save parts of type checking of a function. We do it, maybe the entire function can be reused or not.
Okay.
So it should be fine.
Okay. Yeah, I think this should, for what it stands over here, I think the suggestion should most probably work.
Already removing spans is good.
Yeah, I think I like this association, that instead of, it's like, it's a different way of associating that information instead of having a complete composite, which makes it,
right now, there's also just too many maps. I mean, part of that is that closure captures was meant to evolve into the one true map, but that hasn't happened yet. So the current state is kind of duplicitous or duplicating. So.
Yeah, I think we just need to be a little bit more careful about what span we choose, I guess. Or I think last span should probably work.
You mean like in order? Yeah, as long as it's deterministic.
Yeah. Okay.
I think what you want is probably, it's not like last is fine. When we get into this capturing of paths, we want to pick a representative one, right? Like it may not be the last use. In other words, if the last use was a read, but there was also a write, we want that right.
Yeah, exactly. That's currently we are only relying on the last one because the span is coming from our part dimension and it just puts the last one in. So yes, that was basically why I was, my point was like, if that's working, this should probably work, but it's still not concerning. Okay. Yeah, I think just to give an idea about how much work we're probably getting done over the next 2 weeks is, I think about half of us will have some couple hours over the next 2 weeks to get things done. We're closing in on end of we're halfway through our term, so this is like a big deliverable time for us. But I think half of us have cycles to push work through.
Okay, I think like adapting the data structure described here seems to me to be a fairly straightforward task.
Yeah.
I don't think there'll be any super big surprises along the way.
Yeah. Yeah, it shouldn't be. I might just create a PR for moving the her ID and everything. Should we move creating places also to middle her, like librc middle and her, because I think it will be used in a couple different places. I don't know how dependencies will, basically a strong part of, a good part of mem categorization. I don't know if there will be dependency issues, but
it's currently in what crate?
Type check.
I see.
Because basically everything down here is part of either mer build or middle mer or actually librc mer.
I think that makes sense. I don't think we want to add dependencies to the type check crate.
Yeah.
Just for this, because then any random change in type check would trigger rebuilds of stuff that doesn't need to be rebuilt. This stuff isn't, yeah. I think that makes sense. Then, I mean, there would also be the option of making its own crate for it. it already has to be, sorry, I'm just bringing some of this stuff back in cache. Some of this is in type check results, right? Or type check tables, which is now being renamed to type check results.
Okay.
Side note, but that stuff is already, well,
like,
we already had to move the place definition into the middle crate. Is that right?
Yes, we have to.
So you're talking about basically adding some supporting code for constructing them.
Basically, yes. Currently, well, not the constructor itself, but like the actual categorization part where we do the whole.
Oh, I see. I would hold off on that until we know exactly why. Like, I don't think we're going to use, or
okay.
We might be able to move just some helper functions and so on.
Okay. Yeah, I just want to. Okay. All right. I think
it's fine to move. I just wouldn't want to move it all prematurely. So.
Yeah, that's fair. Yeah. Okay. I think that's all I have. Okay. Do you have any other questions, or does anyone else have any questions?
I guess for my part, I'll just say this is great. Thank you guys for thank you all for like digging in so deeply. It's nice to see it. One thing I would add is I hope that when we finish this work, moving some of this documentation, perhaps well, not this the old state, but documenting the closures better in Rusty Dev Guide would be an excellent.
Yeah, I think Dhruv was also talking about writing some stuff, especially around, I think, setting. I don't remember the exact details. We might be able to add more, but getting set up with this whole environment. And I can move this doc as well once we are done with like actually how we use them later on.
Me and Aman had the same idea, basically, that as I was going through all of these things, there's a lot of context you basically need. And I wasn't able to get all of that from the guide. So I was making notes as I was learning about these things, and hopefully we can move those to the dev guide and make it easy for anyone else in the future.
And I think what would be great is, especially the closure inference and just taking an example closure like you've done, and showing here's the data structures that come out from that. That's the best kind of docs, in my view.
Yeah. What I'll do is I'll keep on updating this. Once the project is done, we can take parts of it, make it more easy for how, like, whatever fits the actual, however it's like the dev guide is worded, we can make some amendments. But I think we can, I can keep updating this doc as we keep making changes to our system. All right, thank you.
Thanks, everybody. I'm gonna have to run now.
All right, see you.
All right, thank you.
Thank you.